Well, good morning or good afternoon, depending on when you're watching this. This is Wednesday's assignment on section 9.2. We are skipping 9.1. Actually, I'm just going to cover a couple things real quick because we kind of need them to head into 9.2. Basically, these two chapters, 8 and 9, or the section in 8 we did, and then 9 is about solving systems of equations. 9.2 goes through some matrix algebra first, and then 9.3 and 9.4 get into how to solve systems of equations using matrices for that. And right now we're still on target to have our chapter 9 test next week, and then we'll move into the final. I'm going to close me out here, and hopefully you got your guided notes here. And the first key here is basically just defining a matrix, making sure we understand how to label them. So a matrix is a rectangular array of numbers denoted by usually a capital letter A, and the rows go across, okay, and then columns go down. Some people say RC, row by column. Radio control is another way some people are used to kind of help remember how the rows and columns are arranged. But we want to talk about a certain position. The row is the first number. The column is the second number. So if you see A2, 3, it is the second row. It is the third column. It is the number in that position. The entry AIJ, like we just talked about, is referred to as the ijth entry. And we write, that would be like the A2, 3. Also with matrices, we talk about the dimensions. Is it a 2 by 3? Is it a 3 by 4? Is it a 1 by 3? That is the row. And then the first number is a row. The second number is the column. Whoops. Now this part here, I'm going to go ahead and before I get into that one, I want to just real quick add something. So let's say A is a 3 by 4. 3 by 4 matrix. So it means I got 3 rows. And it means I have 4 columns. And I'm just going to make some numbers up here. So this is a 3 by 4, 3 rows, 4 columns. If I want to talk about the A12, first row, second column, what is in that position? What number is in that position? That would be -2. If I want to talk about A23, what's in the second row, third column? Second row would be right here. Third column would be here. That is a 5. Okay, A23. If I want to talk about A31, third row, first column, that is a 4. You need to be able to talk about rows and columns in terms of matrices. You need to talk about, positions here. 3-1, A2-3, A1-2. Okay, make sure you understand those. Now it says find X and Y such that this is true. Well, I'm telling you that these two matrices are equal. The only way two matrices are equal are if the numbers in the positions are equal. This is really the first position here, A11. That's a 4. All I know is that X plus Y has to equal 4. We know this 2 equals this 2, this 3 equals this 3, so that's going to be equal. And now I also need to know that X minus Y, which is this position here, has to equal 1. Well, if I'm going to solve this, I basically come up with a system of equations. I got X plus Y equals 4. I got X minus Y equals 1. If I put the second equation underneath the first one, the y's will add up to 0. I get 2x equals 5. X equals 5 halves. And now I need to know what y is. So using x minus y equals 1. 5 halves minus y equals 1. Subtract 5 halves. I get negative y equals negative 3/2. And then I divide by negative 1, y equals 3/2. So in this case here, x equals 5/2, y equals 3/2. So for two matrices to be equal, and this is pretty much common sense, this numbers in the same position have to be equal. All right, some operations here with matrices. In order to add or subtract matrices, they must have the same dimensions. So a lot of times you'll see A is a 2x3. If you're going to add it to B, B has to be a 2x3. In order to subtract those two matrices, they both have to have the same dimensions. Okay, remember dimensions are the row by column. To multiply a matrix by a constant, so just to take like 3 times matrix A or 4 times matrix B, all you do is multiply each element by the constant. It doesn't matter what the dimension is. All right, these two operations are going to come up here. Let's take a look at a couple examples here. All right, take a look at A and B. What dimension are both of those matrices? Okay, make sure you understand those are both 2x3. 2 rows. Rows are horizontal, columns are vertical. Well, what does 4A mean? 4A means that you just take 4 times each element in matrix A. So 4A is going to be 4 times 2 is 8. 4 times negative 4 is negative 16. 4 times 5 is 20. And I multiply it by negative 3. I get negative 12. I get 28. And I get negative 4. So that is scalar multiplication with matrices. Just take whatever the constant is times all the elements. A plus B, only way to add two matrices if they're the same dimensions. These are both 2x3s. And all you do is you add the corresponding elements. So whatever's in row 1, column 1, you add with row 1, column 1 there. And I get negative 4. And I add negative 4 plus negative 2 is negative 6. 5 plus 10 is 15. Negative 3 plus 8 is 5. 7 plus 0 is 7. And negative 1 plus 4 is 3. So that's A plus B. Got to have the same dimensions, add corresponding elements. All right, those are the same two matrices. I just have them written down for my benefit. Okay, 3B minus 2A. All right, so what's 3B? And that's, now be careful here. B's the one on the right. Okay, so 3 times B, 3 times negative 6 is negative 18. 3 times negative 2 is negative 6. 3 times 10 is 30. 3 times 8 is 24. 3 times 0 is 0. And then 3 times 4 is 12. All right, now you got to watch here. 3B minus 2A. So think about this. You really only want to multiply the A by 2. If you multiply it by negative 2, you got to make this a plus sign. Okay, so just be careful here. So just multiply the A by 2. I get 4. I get negative 8. I get 10. I get negative 6. I get 14. I get negative 2. Now you subtract. Negative 18 minus 4. Negative 22. Negative 6 minus negative 8, which becomes a plus. Positive 2. Negative 18 minus 10 is negative 28. 24 plus 6 is 30. 0 minus 14 is negative 14. And 12 minus negative 2 gives me positive 14. So I got 3B minus 2A. This matrix would be my answer. All right. Erase this down here. Here are your rules. Not that you have to memorize these or anything, but just kind of going through here. A plus B is equal to B plus A. Okay, if you add those in, doesn't matter what order you add those in. Associative property also works. A plus 0 equals 0 plus A. So if you add the 0 matrix, you're just going to get back the same matrix. Okay, all these apply as with typical integers. Okay, now it says solve the matrix equation 3a plus 2x equals 4b for x. Now let me do something here. Let me just take 3a plus 2x equals 4b. And now a, b, and x are all matrices. And now in order to do this, you would normally, or we would subtract 3a. And I would get 2x equals 4b minus 3a. Well, at this point, we haven't divided by matrices. And actually, that's something that we really don't have the capabilities to do at this point. But we can multiply, and then it'll get rid of the 2. We're going to multiply by the reciprocal of 2, which is 1/2. So that means 1/2 times 2x is going to equal 1/2 times 4b minus 3a. And so x equals 1/2 4b minus 3a. So that's what it's going to end up equaling. Now I can go through this step by step, or you can just start right here. So just think about this. It says 3a plus 2x equals 4b. Well, what is a? A is 2046. I don't know what x is. That's what we're looking for. Equals 4. And then b is 1352. Now I'm going to do a little work here. I'm going to go ahead and subtract. I'm going to put 2x equals 4 times 1352, that matrix, minus, and I'm subtracted this whole thing, 2046. All right, I'm going to go ahead and distribute and then subtract. So I get 2x equals, what do I get here? 4, 12, 20, and 8, minus, distribute the 3, I get 6, 0, 12, 18. Now, I don't know if I left you enough room on that one. Hopefully you write small. But 2x equals, and then 4 minus 6 is negative 2. 12 minus 0 is 12. 20 minus 12 is 8. And 8 minus 18 is negative 10. Now, the last thing we need to do, we said we need to, x is going to be 1/2 times that matrix. So in the end, x equals 1/2 times negative 2 is negative 1, 6, 4, negative 5. Okay, so that's how we solve that matrix equation where A, X, and B all represent matrices. For that. So we've added and subtracted. We've multiplied by a scalar. We've taken an equation, matrix equation, and solved. Now here's one of the more important things is multiplying matrices. And now multiplying matrices, for adding and subtracting, they have to have the same dimensions. They can have the same dimensions, but that doesn't mean they can be multiplied together. Here's the key for multiplying two matrices. the column of the first matrix must match the row of the second matrix. So when you look at their dimensions, okay, the column of the first has to match the row of the second, and then the answer will have the outer dimensions as the answer. So just real quick, make sure you understand it. So if A is a 2 by 3 and B is a 3 by 4, you can multiply those together because the threes are the same, and the product will be the first. It will be a 2 by 4. Okay, that'll be the case. If C is a 3 by 4 and D is a 4 by 1, you can multiply those together because the inner values are the same, and then the answer will be a 3 by 1. So that's how you go about and you multiply two matrices. They have to have the inner dimensions the same, and then the outer dimensions will be the answer. All right, let's take a look at a case here. It says find the products AB and BA, where A is a 2 by 2 and B is a 2 rows and 3 columns. So 2 by 3. Okay, now AB, the product. Here's how we multiply matrices together. And I'm going to rewrite these. I'm going to write 1, 2, -1, 3 times 3, -2, 1, 1, 2, 3. The answer, so I get a 2 by 2 times a 2 by 3. My inner dimensions are the same. The outer ones here will be the product. So my answer has to be a 2 by 3. And here's how we figure out what that 2 by 3 is. And I'm going to leave myself a little bit of room to do some work here. Okay, to get the first row, first column, here's how this works. You take the first row, row 1 of the first one, and we're going to multiply it by the columns of the second one. Okay, now this row 1 times column 1 will give me this spot here. Now here's how you multiply. You take the first term times the first term. So we take 1 times 3, and now we always add plus, and then you go across the row and down the column. So you go over to the 2 times a 1. So multiply 2 times 1. Now, and then we add those together. What do we end up getting for that spot? We get 3 plus 2. We get 5. That's going to be that final answer for there. Now I go row to get this next spot. It's row 1, column 2. So I go row 1 times column 2. So it's 1 times -2 plus 2 times 2. And then that gives me -2 plus 4, which is 2. So that's going to be in that spot. And then row 1 times column 3. You keep going all the way across the columns. That's going to be 1 times 1 plus 2 times 3. Well, that gives me 1 plus 6, which gives me 7. Okay, 1 plus 6 is 7. All right, now let me do this. I'm going to go ahead and delete those, because now what you do is you work down to the next row. We did the first row times all 3 columns. Now I go to the next row and do the same thing times all 3 columns. And I just work my way across. -1 times 3 plus -1 goes across, and then this -1 times that 3, and then 3 times 1. and that gives me 0. Okay, those add up to 0. And now I go across to the next column. -1 times -2 plus 3 times 2. It gives me, that's going to be a +2 plus 6 gives me 8. And now go to the third column. So -1 times 1 plus 3 times 3. And then when I combine those, I get -1 plus 9, which is 8. So here's my final answer. It is a 2 by 3 with 5, 2, 7, 0, 8, 8. Okay, that is our product, AB. Now it says find the products AB and BA. All right, well, if we take a look at BA, B is a 2 by 3 matrix. A is a 2 by 2 matrix. The two middle numbers do not match up. You cannot multiply those together. It is undefined. Okay, it is undefined. And now here's why. If you think about this, I'm just going to write this down. Here is B, 3, -2, and then 1. And then I got 1, 2, 3 times 1, 2, -1, 3. When we multiply, we do row times column. We take this row times this column. Well, you take each element of the row times an element of the column, and here's what we do is we run out. 3 times 1 works, -2 times -1, but this 1 doesn't have anything to multiply by. So this is why the row and the column must match on the inside, is so that we have the same number of elements going across as we have going down. If we have a different number of elements across versus down, then that is undefined. So this kind of leads us to an issue. We know when adding matrices that A plus B, doesn't matter what order, that A plus B is going to be the same as B plus A. In regular multiplication, if I multiply two numbers together, A times C is the same as C times A. But I have AB is this answer, and BA is undefined. So that leads us to the case that matrix multiplication is not commutative. Okay, matrix multiplication is not commutative. Okay, A times B does not equal B times A. In some instances it can, but it does not equal it, does not have to. Okay, so that's kind of a huge point for matrix multiplication. Cannot assume that at all. Now here are some properties of matrices. Associative property works. Okay, if I do A times B first and then times C, I'll get the same answers if I do B times C then A. Okay, the distributive property works with matrices. Okay, and then if I have a scalar, I can technically multiply it by the A or the B first. Doesn't matter. Okay, but it is not commutative. All right, now you need to be careful here on a couple of things, especially when you square something. Okay, especially when you square something, you have to be careful of what the answer is going to be. Now, we still got to follow our rules in terms of order of operations. So if I got parentheses A plus B squared, I have to do parentheses first. I have to add those together. And now, so I got 2, -3, 4, 1 plus -1, 2, 5, 6. And that's going to equal 2 plus -1 is 1. -1, 9, and 7. Actually, not 7 because that, oh, B, that should be a -6. And so this should be -5. So I got 1, -1, 9, -5. All right, here's what you got to watch. When you square something, okay, we're going to square that. You do not write this down. You do not just square the individual terms and call it a day. Like you do not do 1 squared, -1 squared, 9. No, that does not work. You have got to be very, very careful about that. Okay, because here's what you have to do. Just like in good old fashioned math, if you square something, you write it down twice. So I take 1, -1, 9, -5 times 1, -1, 9, -5. And I use my good old matrix multiplication rules where I take row 1 times column 1, which is 1 times 1 is 1, plus -1 times 9 is -9. I end up with an 8 there. Now again, since this is multiplication and I got a 2 by 2 times a 2 by 2, the middle numbers match up and the end numbers are also the same, so the answer has to be a 2 by 2. Move across the row. 1 times -1 is -1. -1 times -5 is 5. Add those together, you get 4. Okay, so now I did row 1 times both columns. Now you move down the rows. Go to row 2 times column 1. Well, what's that give us? 9 times 1 is 9, plus -45. That adds up to -36. And then row 2 times column 2, that's 9 times -1 is -9, plus 25 gives me 16. There's our final answer. Okay, A plus B quantity squared for this one is 8, 4, -36, 16. It is a 2 by 2 matrix. So there's a lot going on here. And one thing is when you square something, do not just square the individual terms. You got to write it beside each other. All right, same matrices. I just have them down there for me. A squared minus B squared. Okay, you got to square A first. You got to square B first, then subtract. Well, A squared, you have to take 2, -3, 4, 1 times 2, -3, 4, 1 minus B squared is -1, 2, 5, -6 times -1, 2, 5, -6. So I got to do order of operations. So I got to square these. Row times column. And since they're both 2 by 2s, my answer is going to be a 2 by 2. And what do I get for here? 4 minus 12, -8. Times column 2, -6 minus 3 gives me -9. Okay, now second row, first column, I get 8 plus 4, which is 12. And then I go second column for -12 plus 1, -11. All right, let's see what you come up with for multiplying those two together. row 1 times column 1. So I get 1 plus 10. So I end up with 11. Okay, now for the others, I got negative 14. I got negative 35. And then I got 46. And now the last thing I need to do is subtract those. So negative 8 minus 11 is negative 19. Negative 9 plus 14 is 5. That should be a 5. 12 minus negative 35 should be 47. And then negative 11 minus 46 is negative 57. All right, one thing you really, really have to watch is the squares. Do not just assume you square the individual terms. That does not work for that. All right, so we went through how to add matrices, scalar multiply, solve a matrix equation, and then how to multiply. Multiplying being the most important one, or maybe the most difficult one. All right, page 895. The following problems. So I got an extra space in there. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, we're going to do section 9.3 Thursday. Nothing on Friday. Come back 9.4 on Monday. Kind of review, and then we're looking to have that test on next Thursday. All right, over chapter part of 8 and then the rest of 9. All right, everybody have a great day, and remember, stop by the campus conference, double check your homework once I've graded it. I like to make some marks on some of them or make some comments. Not always, but especially if you're missing a couple, I will mark, at least try to put some marks on there. All right, have a great day.